Welcome to AmeenAcademy.com. In complex analysis, let us discuss about an overview of complex numbers continuation. Here, first we talk about some properties of conjugates. Properties of conjugates. Here, first, what is conjugate? Here, look at this diagram here. This x-axis real, it's a imaginary. Now, the point here, so represent z is a complex number x plus iy. Here, the conjugate of this complex number is nothing but it is here this reflection about x-axis, that is here. This is a conjugate of this complex number z, that is x minus iy. Now some properties we'll explain one by one. Here, first one, conjugate of a complex number is the complex number. That means conjugate of a conjugate number, that is conjugate of a conjugate number is a only z. This suppose here z equal x plus iy, then which gives z bar equal x minus iy, then z bar of bar, that is conjugate of conjugate is x, change the sign further, this minus s plus. Second, if z equal z bar, then if only if z is purely real. Suppose any complex number is equal to conjugate of that complex number, then that complex number is purely real. Z is x plus iy, then z bar is x minus iy, that is x plus iy equal x plus iy bar, because z equal to z bar. Now further x plus iy is x plus iy bar is x minus iy. Then cut both x and x, then collecting iy plus iy equals 0. Therefore 2iy equals 0, which gives y equal 0 over 2i equals 0. So we have y is 0, then imaginary of z equal to 0, therefore which gives z is purely real. Here because imaginary part is 0 in this complex number, then you can say Z is only purely real. Then third property, the conjugate of the sum of two complex number is the sum of their conjugates. That is, Z1 plus Z2 is equal Z1 plus Z2. So not only these two, in general, Z1, Z2, Z3 like it goes is equal Z1 plus Z2 plus Z3 like dot dot dot, means sum conjugate of the sum of the complex number is conjugate of the integer complex number. Then fourth one, you can prove it. Suppose if you put x1 equal to z1 equal to x1 plus y1 and z2 equal to x2 y2, then add them, put find the conjugate of that one, and we can get it in separate sum of separate conjugate numbers, conjugate of that complex number. Then fourth, the conjugate of the difference, same the difference also, z1 minus z2 is same as z1 minus z2, as well the here whole conjugate z1 minus z2, conjugate of z1 minus z2 equal conjugate of z1 minus conjugate of z2. 5. The conjugate of the product of two complex number is the product of their conjugates, means same z1 into z2 equal z1 z2. Even this for continuous things also, that are z1 z2 z3 like is equal z1 z2 z3 like also. Even you can prove this also. Then sixth one, the conjugate of the quotient of two complex number non-zero denominator is the quotient of their conjugate. That means z1 over z2, the common conjugate, is equal z1 conjugate by z2 conjugate. In general, you can write z1 z2 z3 z4 z5 z6 like it goes, all conjugate equal, separate that one also, z1 by z2 z3 by z4 then z5 by z5 like it continues. Next one, the square of the conjugate of complex number is equal to the conjugate of the square. Here z1 whole square is equal z square z1 bar whole square equal to z1 square bar. Now we can check this one. Let z1 equal, in general you can z1 equal x1 iy1 Now z1 square equal x1 iy1 square equal x square plus iy square plus 2x1 y1 2x1 y1 I. So which is equal x square. Here I square is minus 1, so minus y1 square plus 2x1 y1 I. So we have to separate, right, x1 squared minus y1 squared plus 2x1 y1 I. Now z1 square bar is nothing but change the sign of the imaginary part. Z1 squared minus y1 squared minus 2x1 y1 I. From equating to this one 1 to then from here z1 square we have to do from that z1 square whole bar we have to do is x1 square minus y1 square, change the imaginary part sign, so it is 1. From 1 and 2, from 1 and 2 we are saying, we can say z1 squared bar is equal z1 bar the square. Now let us do some examples problem. Find the conjugate of find the conjugate of 1 minus I over 1 plus I. Now first we'll write 1 minus I by 1 plus I, rationalize the denominator 1 minus I over 1 minus I. Here down is 1 square plus 1 square. 1 minus I whole square is 1 minus 2I plus I square, which is equal 1 minus 2I. I square is minus 1 by 2, which is equal minus I. So minus, therefore conjugate of 1 minus I 1 plus I is plus I, because conjugate of minus I is plus I. Now we'll continue further videos for further explanation. We have done. Please subscribe our YouTube channel.